Okay, so year 11 mathematical methods. So this is our first lesson on conditional probability. Okay, we are going to do 3 lessons on conditional probability, which is a very important part in our study of probability in year 11. Okay, first, we need to understand what do we mean by conditional probability. We use the symbol like this. Okay, so it's symbol like a probability of A given B, alright? So it's probability A given B. So for this type of probability, it's like it's given an event has happened. So if it's probability A given B, that means you know event B has happened, and you need to understand what's the probability of A. Okay, and one reminder, don't confuse with probability of A and B. Well, what should we say is probability of A intersect B. Okay, so that would be the basic idea. Don't confuse with A intersect B. There are differences. For A intersect B, that means both events must happen at the same time. Okay, must both happen. But for conditional probability, one of the two events is already given as being happened. Okay, so all you need to do is to find under the assumption that B has happened, what's the probability of A to happen. Okay, so to make things more precise, let's have some illustration. How could we use certain vocabulary to represent probability of A intersect B and probability of probability of A condition on the other probability, or B on condition A. Okay, so for example, if I got two events, first event is getting an even number by rolling a die. B is getting a multiple of 3 by rolling a die. Okay, so probability of A intersect B means the probability of getting an even number, which is also multiple of 3. Okay, so you could imagine that will only be one number, which is 6, which is an even number, also a multiple of 3. Okay, and for the probability A on condition B, that's a very important word here. You see the word given. Okay, so for A on condition B, you should say probability getting an even number, given it is a multiple of 3. Okay, so given you already know it's multiple of 3. What's the probability of getting an even number? Alright, and for the probability of B given A, okay, so the description should be the probability of getting a multiple of 3. You see, it becomes the probability of getting a multiple of 3 rather than even number. But given it is an even number. Okay, so this time it's already known that the number is an even number. Okay, under such a condition, you need to find the probability getting a multiple of 3. Okay, right, so let's have some exercise. Okay, so if A is getting a spade by drawing a card from the deck of 52, B is getting a king by drawing a card from the deck of 52. Okay, so there's a bit of grammatical mistake. Let me fix it by drawing a car. Okay, A is about a spade, B is getting a king, right? So how could we write probability of A intersect B, right? And so the description should be the probability of getting a spade, which is also a king when drawing a card from the deck of 52. Okay, so that would be the description. Okay, so let's write another one for the conditional probability for A on given B. Alright, so in this case B is the condition, so what should you write? Okay, so it should be the probability of getting a spade by drawing a getting spade. That would be okay. Given it is a king when card. Okay, I think that would be good. Alright. Okay, so how about we swap the condition and the event. Alright, so this time the condition becomes drawing a card, getting a spade, right? The probability is about getting a king, so this will become the probability of getting a king given it is a spade. Okay, all good. So that's how should we describe the intersect or the events of two, the probability of two should be the probability of the intersection of two events, or the conditional probability of one event given the other. Alright, so there are different types of descriptions and different and you need to see the keyword for conditional probability. Okay, right, so in terms of calculation, what kinds of notation are we going to use? Okay, for the probability for A, okay, you simply use number of, so that's our fundamental definition for probability of certain events. So that's a number of outcomes in event A divided by the number of total outcomes in the universal set. Okay, but if that's probability of A given B, then since you've already know that B has happened, so we are going to narrow down that the set for consideration. If that's just for probability event A, you need to consider the whole set of the whole universal set. That means U. Alright? But since you've already known that B has happened, so you only need to consider all the outcomes in the event B. All right, and also you don't need to consider part of some of the outcome in A which is not in B. So that's why you need to change that A into A intercept B. So that means you need to narrow down that the denominator also the numerator from the definition or probability of A. Okay. Alright, so let's have some examples to look at. What shall we do? Okay, a fire die of 6 sides is rolled. Determine the following probability. Okay, A, the probability of getting an even number, which is also a multiple of 3 by rolling a die. Okay, so you should see two events here. One is getting an even number, which I shall denote as A. Okay, the other is, which is also multiple of 3 by, okay, so that's B. Okay, so A is an event getting an even number, B is an event of a multiple, being a multiple of 3. Okay, so what kind of probability you are looking for? Because you are looking for event which you get an even number, but also another event, multiple of 3, they happen together. Okay, so this time for this kind of description, it should be the probability of the intersection of two events. So this time you are looking for A intercept B. Okay, because two things must both happen. Okay, good. B, the probability of getting an even number, given it is a multiple of 3. Okay, so for this one, the probability of getting an even number is A, given is multiple of 3, so it's a B, right? But that's a very important word here to make it different to what we are asking in B. So given. Okay, so if it's given, that means we've already understood that it must be a multiple of 3 in the first place, and then you are going to find a probability which give you an even number. Okay, so this will be a conditional probability of A unconditional of B. Right, for C, the probability of getting a multiple of 3, given. Okay, again we see this word given. It is an even number. Okay, so getting multiple of 3, and oh sorry, there's a confusion of colors. So this the other way around. Okay, so you've already known that is even number. So how about multiple 3? Okay. Okay, so if you got three definitions, right? So how can we do them? Okay, so if you just consider separately the probability of A. So probability for A is just an even number. So we know there are 3 even numbers and there's 6 outcomes, right? So it's 1/2. And when you consider B is multiple of 3, there are only 2 multiple of 3, which are 2 and 6. Okay? 3 and 6. So 2 out of 6, which is 1/3. Okay, so you got probability for A, you got probability B. Could we just could it just be enough for us to find probability A intercept B? Okay, in this case, you can't just multiply them. Okay, let me show you why. Okay, so a better way to do it is to either use the Venn diagram, or you might use two-way table. Alright, so let's use Venn diagram first. Okay, so let's try to understand if we are going to draw a Venn diagram, because we know there must be some intersection between A and B. Okay, so here's A, here's B. Okay, so what's the intersection of A and B? So A means getting an even number, B getting a multiple of 3. Is there a number which is both an even number and also a multiple of 3? Let's write the set. Okay, for even number you got 2, 4, and 6. For multiple of 3 you got 3 and 6. Okay, do they have any intersection? Yes, we got 6. Okay, let me draw it. Okay, so it's 6. So we know that's how to draw a 6, right? 1, 2, 3. Okay. Okay, so that's the only common outcome from the two sets. Alright, and for A, there should be two other cases. One is like this. Okay, there should be another one. Okay, for A, you got 2. Okay, and another 4. And for B, you should have another 3 here. Let's change the color. Sorry, more sets by doing things perfectly. So there are 3. Okay, so there are only 4 outcomes. We know there should be 6 outcomes, right? So where are the other 2? Okay, so let's have 1 here, which is 1, and also we should have 5 as another one. So for 5, may I just copy this one and let me put it here. Okay, so let's try to find PA intercept B. For P probability A intercept B, you need to find number of outcomes, which is in the set of intersection of two sets. And since this is not a conditional probability, we are going to consider the universal set. Okay, so how many outcomes in the intersection? Just 1. Okay, how many are in total? Just 1/6. Okay, so let's do another one. So for B is A given B, right? Probability for A given B, right? So you need to find, by definition, should be A intercept B also. But you need to narrow down the denominator as well. You need to reduce it. Okay, so in B there's only 2 of them, and also A and B, there's 1 of them. Okay, this case we should have this one. Okay, A intercept B, how many of them? Just 1. And how many of them in A? There's 3. Okay, 1 over 3. Okay, so you see, how could we do this? You need to actually work on the Venn diagram. Okay, and you need to make sure you understand to use the symbols and the set notations, and need to find the number of outcomes. Okay, for each set or the intersection of sets. Okay. Oh, good. Okay, so that's our first example. Let's do another one. Okay, a card is drawn from a deck of 52 playing cards. Calculate the following probabilities. Okay, so A, getting a spade, which is also a king. Okay, so there are 2 events, are they? Okay, let's see. So that's what we call S, that's what we call K. Okay, because that spade is also a king, so that means you are getting a spade king. So let's say this event should be S and K, right? The second one, getting a spade, given it is a king. Okay. Okay, the third one. Okay, again you see the word given. Getting a king, given it is a spade. Okay, so how could we do this thing? How could we find? Alright, okay, so let's just first draw the Venn diagram. Okay. Okay, so this time, since there will be too many cards, so I'm not going to do the things like my previous example. I'm not going to draw all the cards, right? So that won't be enough space. Okay, so let me just try to find spade. How many spades are there? So there should be 4. Okay, there should be 4 spades. How many king? Oh, sorry, spade. There are 13 spades. How many king? There should be 4. Okay, so how many cards are both spade and the king? There's only 1. Okay, so let's write 1 here. So 1 means there's only 1 card, which is spades and the king. But we know there are 13 spades, so it should be 12. Here should be 3. Okay, but we know there are 52 cards, so how many are outside? Okay, you need to do a little bit calculation here. So it should be 52 minus, so there are 16. Okay, so it should be 36. So there are 36 cards outside. Okay, and okay, so let's see how could we find the answer for the first one. Okay, probability spade and king, there's only 1. Okay, so we shall write the thing like this. Spade, given this one is a king. Okay, again, oh sorry, I think I got something wrong. I got too quick. Sorry. Should be this. Okay. Sorry. Okay. And number of king and spade just 1. There should be number of spade 13. Okay. So that will be the answer. All good? Alright. Okay. Okay, so for number 3, possibly I should give you a try. Okay. So again, there are 2 events, namely studying French as a language and or study Chinese. So it's FC. Okay, so 2 events are FC. Okay, so you are going to draw a table, draw a Venn diagram to help you to find the numbers, right? Find the answers. Okay, so pause now. Okay, so this question is a bit different from the previous one. First, you need to draw the Venn diagram. Okay, so remember to draw the Venn diagram, you always try to find the intersection first. So because there are 10 students study both Chinese and French, so you need to write 10 here, because you know there are 15 students study Chinese only. So those students who only study Chinese, not both Chinese and French, there are only 5 of them. Okay. And for some students who study French and also who study French and but not Chinese, there are 10 of them. Alright, so there should be some students study neither Chinese nor French. So those are students are 15, because you know the total will be 40. You use 40 to take away 25. You got 15. Okay. And from that, you need to judge what kind of probability is in A. So a student randomly chosen for a group studying French, calculate the probability they also study Chinese. Okay, because the student has been randomly chosen for the group studying French, so it's given the student must be studying French in the first place. Okay, so for this one, it should be like Chinese and French. Okay, for B is chosen from a group studying Chinese. Okay, for C, studying both French and Chinese. Okay. Okay, so let's have a look. Okay, so during COVID-19 lockdown, students need to study online. On a survey of 50 students, it is found that 20 of them watch videos, 35 of them use textbooks, and 10 of them neither watch videos or use textbooks. Okay, so a student is chosen randomly. Find the probability of students is using both videos and textbook. Okay, so you need to find the probability. Okay, so there are 2 events. Okay, sorry, videos and textbooks. Okay, right. Okay, so you need to think, how about A, what kind of probability it is the student is using both videos and textbooks. Okay, so that would be the case. For B, the student is using videos, given it is known that they are using textbooks. Okay, it's using videos, given. Okay, so you see the word given, so it's very helpful to know this word. Whenever you see this one, it's possibly conditional probability. Okay, so alright, all good. Okay, so I'm going to give you some time to work on this. Okay, so because this one is a little bit difficult than the previous one, okay, I would let you to have some time to try to draw the Venn diagram first, and after that, if you could do A, B, and C, then I'm going to show you how to do D and E. Okay. Okay, so here are the answer for the first three parts. Okay, for A, you need to be careful that's because it's not given how many students watching videos and also using textbook. It's not given, but it's the intersection that you must know first. So that's why you make it X. Okay, and that's one technique which is very important for you to use the Venn diagram. You always need to find the intersecting part first. If it's not given, you need to let this part be X. Okay, right, so after that you can just for example the part that's watching video only but not reading textbook, it should be 20 minus X because totally there are 20 students using videos. Alright, so similarly there will be 35 minus X who reads textbook only. Okay, and outside there will be 10 because it's given there's 10 students neither watch videos or use textbooks. There are 10 of them. Okay, so let's see what happens. Okay, and if you got these Venn diagrams correct and you add all the numbers, you should be 50. So that's why you got X equal to 15, right? And that's X will be the intersection between V and T. So that means the intersecting events between V and T will give you 15 divided by 50, alright? And that will give you 3 over 10, alright? So the other event is probability V given T. Okay, so that's B. Using videos, given it's known they are using textbook. Okay, so they are using textbook. It's you know that it's known that they are using textbook, but you want to know the probability they are using watching videos as well. Okay, so that would be the probability. Then you will use the intersection of V and T divided by that number of students watching using textbook. Okay, so it should be 15 divided by 35. It will be 3 over 7. That's it. And C would be the other way around. So probability using textbook, given that you know they are using videos. Okay, so it would be 15 divided by 20. Okay, so you should understand this not by now. Okay, so part D, the student is using video, given it is known that they are not using textbook. Okay, so it's quite interesting. Okay, so using videos, but given they're not using textbook. Okay, so what kind of probability it is? Okay, so it should be the probability like probability of V given not using textbook. Okay, so to find this probability, you need to do, okay, let me write here, not enough space. Okay, so they're watching videos but no textbook. Okay, watching videos but no textbook. Which part? You should be watching video, no textbook. This part? Okay, so X is 15. So that means it should be 5 of them. Okay, and number of people not watching videos, here. Okay, so it should be 5 plus 10 should be 15. Okay. Okay, that's it. Okay, so that's part D. Okay, let's do part E as well. Okay, I use another color. Student using textbook given it is known that they're not watching videos. Alright, okay. So they're using textbook but not watching, given that they are not watching videos. Okay, so this is the probability. Okay, again you see this is a conditional probability. Okay, and let's do it, and it should be like okay, so this is about using textbook but not watching videos. Okay, so using textbook, not watching videos should be here, right? So X is 15, 35 takes 15, 20, okay? So it should be 20 over here, divided by number of students not watching videos. Okay, not watching videos should be here, here. Okay, should be 10, and you take away 15, so that would be 20, so there are 30 of them. Right, and 2/3. Okay, that's how we do question D and question E. Okay, and okay, question 5. Since that the video is already too long, I'm not going to do it. So possibly I'm going to give you as an exercise. Okay, so for part A is conditional probability. Okay, so again there are two events. So studying mathematical method, studying physics. Okay, so there are two events. Okay, so let's say for this one, the first one is given there as study physics. For the second one, studying physics, given they are studying mathematical method. Part C, studying mathematical methods, given they are not studying physics. Okay, part D, students studying physics, given they are not studying in mathematical methods. Okay, so there are four conditional probabilities. Okay, let me give you the answer. You could have an exercise. Okay, so that's it. Okay, and okay, so another way to do it is to use tables to help you to find the conditional probability. Okay, so for example, so for this example, 100 students were questioned and classified according to their attitude towards online workload and usefulness of online videos. The results are shown in the table. Okay, workload is too stressful, so let's call this W. Not stressful, that means this one. Videos are useful, this one. Not useful, this one. Okay, So basically, so if I give you the number of students, so this means number of outcomes in the intersection between W and V, and this one's in the intersection of W and but not in V, and this one is in the intersection of not W but V. This one is not W and not V. Okay, all right. And okay, so we understand that 60 means all people, all elements in V, and this means all elements not V, and N, so 100 will be all element in the universal set. Okay, and that's 50 means here. All right. Okay, so let's see how could we use this table. Given the selected student feels the workload stressful. Okay, so you see the word given. Okay, so that make this statement stressful as a condition. Okay, calculate the probability they find the video useful. Okay, so for this one is the probability of the video useful, that's PV, on the condition is too stressful. Okay, and for this one you need to find this. Okay, oh sorry, I should use W. Sorry about my, so let me rewrite this. Okay, sorry, I should use W, so because workload is W. And okay, so B, given the selected student finds the videos not useful, okay, calculate the probability they feel the workload not stressful. Okay, so you must follow the condition. Okay, so that will be the case. All right. Okay, and the last question is, again, there are two events. Okay, so, and it's about questionnaire about age and whether they are using social media. Okay, so there are two groups, age less than 25 or age greater than or equal to 25, and the answer is either yes or no. Okay, so there are totally 500 students, 500 questionnaires. Okay, one person select a random from 500. Given that, okay, again the word given that the select student is less than 25 years old. Okay, so the condition now is less than 25 years old. Okay, find the probability they regularly use the social media. Okay, so the probability is yes, but then on the condition the age is less than 25. Okay, so you need to find yes and age less than 25. Okay, how could we find the number of answers which is yes, but from those younger than 25 years old. Okay, so should be this number. Okay, and the total number of people who is younger than 25 years old. Okay, should be this number, 240. Okay, so that's it. Okay, and so that's our first lesson on conditional probability. Okay, thanks for watching. See you next time. Bye.